Here's tokenizing a string. If you tokenize it, here's a string toke S1 and S2. Yeah, you remember we used this back in the videos on talking to the web, working with the internet. We call it repeatedly. Usually these things happen in a loop over and over and over again, but I'm going to show you just one by one so we can walk through it. Let's say that this is our entire piece of data coming into our program, and we're going to run our CGI program, and our parameters are val equals 1, ampersand, val 2 equals 2, ampersand, val 3 equals 3. We will read this off in our request variable and get this stuff into S1. So now S1 is equal to val equals 1 and so on and so forth. When we call string toke the first time, we pass it S1. We pass it the beginning of this string and what we wish to use as tokens. In our case, it's only the ampersand is all we care about as a token. If we wanted to use other values in here, we could, other tokens. But on the internet, the ampersand is the token that separates these values, these value pairs, I should say. When this call is done, when string toke is finished, first we'll be pointing to val equals 1. It will be set to the beginning of that little string, all right, and nothing else. That's what's right there. Then we call string toke again, because since we got a value back, we know there's more to be parsed. And I have a typo there, sorry. Here's a strtok again. This time we pass null, or 0 as the pointer. Well, string toke remembers it's working its way through S1, and right now it's looking right here, because it found this first ampersand, and now it's parked there. So if we pass it a null, looking for another ampersand, it will work its way down the string until it finds another one, and it will return the beginning of this string to second. So now second points to val 2. Since we didn't get a null, we call it again. And we would, of course, be sitting in a loop doing this until we finally hit a null. We do string toke again, pass it a null and an ampersand. We're pointing here now, and we're going to run down to the end of the string, which is a null, and we're going to sit right there, and we're going to pass back the beginning of this string. So third is equal to val 3. So we have tokenized the string and removed the tokens out of it. We didn't get a null, so we call string toke again with a null pointer, because we wanted to continue down the string, but it is already pointing at the end of the string here. It's not going to find an ampersand. It's going to sit there and return null. So fourth is equal to null, and our loop will end. So that's how you use string toke and how we used it earlier to tokenize a string. Very powerful little function, a nice thing to have around string toke. And here's the end of string.h. We have our mem copy. Mem copy copies the whatever's in memory from string 2 to string 1 with a number of bytes. Mem move allows overlap. If string 2 is just a little bit down within string 1 someplace, we can copy it, kind of ripple it up to string 1. Mem copy can't do that. It'll be corrupted if you try to use it on strings that are within each other with overlap. Mem compare is the same, return a string compare, less than, equal, or greater than values based on S2 being subtracted from S1 for a number of characters. Mem compare, however, does not care about null bytes and strings. It strictly works on the n number of bytes or until there is a difference. So once there's a difference between these two, the less than or greater than will be returned. If we get to n number of characters without a difference, then we know that a 0 will be returned and they're identical. The two blocks of memory are identical. Here's a mem char. We're looking for this character someplace beginning in this memory for this number of bytes. And wherever we find it, if we find it, will be returned in where. If we do not find it, it will return a null or 0. And here is memset, the final memory function of the standard string.h, and memset will set the memory pointed to by S1 to whatever C is, usually a 0 if you want to clear the memory. But you could clear it to an A or an F or whatever else you might want to, and then this is how many bytes to clear, usually the size of this buffer. That's a good way of clearing out memory. Sometimes in secure programming, you need to do that before you release the memory. Because your client, I had a client like that did not want anything laying around in memory for some hacker to look at. So you do a memset of your buffers before you release them, clear them, and then release them, and they're not laying around in memory. So that is the end of string.h. Moving right along.